Okay, we're on the section of inverse functions. You learned about inverses in Math 119. Same stuff applies. Test for invertibility, yada, yada, yada. All right, we'll go through this, but I want to point out it's probably in your interest to read what we give you. And it would certainly be great if you could read it before coming to lecture, but whether you read it before lecture or after lecture, you have to start reading. And we try to not give you too much to read. Certainly not like a textbook, that kind of level of difficulty, but by my read, for example, inverses were covered in 119, no doubt about it. We're doing trigonometric functions now. In 119, a definition is given to you. This is actually the same notes I used for 119. They get a definition of a one-to-one function. And again, it might be hard to understand, but the bottom line is, in 119, hopefully the teachers really boil it down to not a verbal problem for you, although it really is a verbal problem. Mathematics, mainly verbal. They boiled it down to a problem where, they talked about, a function is one-to-one if no horizontal line intersects graph more than once. So this is a really good example of a function not one-to-one. Now, the deal about this is only one-to-one functions are going to be invertible. All right, so I'm going to say this one over here is not invertible. This is what you learned about Math 119 when you did inverses. The first thing you did was you graphed the problem. And then what you did was you looked at it and said, oh, was it invertible, right? Now, if it wasn't invertible, you could break it into pieces and invert it. But the bottom line is you didn't do that in 119. We're going to do that in 120 though, all right? The problem with the horizontal line test is that sometimes it can be very deceptive. For example, this graph over here, it's the graph of this thing over here. This is actually an invertible function, but if you look at it, if you drew a horizontal line, it looks like it goes through more than once in this region over here, but it doesn't. And this was known as an artifact of the graph. The graph, although it's abstract, it's always increasing. And the line, no matter what horizontal line we draw, it only intersect one. This is an example of an invertible curve. All right. So we're not going to get that level of difficulty over here, though. But if you read through that, you'd see that. All right. Let me just talk through this over here. Just to remind you did 119, same definitions, nothing changed. It said let f be a one-to-one function. Now, what does that mean to me when I graph it? A horizontal line only goes to it at most once. Domain A, range, domain A and range B. Then it's inverse, F inverse. By the way, this is not reciprocal. It's read as F inverse. Has a domain B and a range A. Just exactly what you did in Math 119. Exactly the same. No different. No different. So what are we going to do now? We're going to go to the whiteboard and I'm going to talk about the inverse trigonometric functions. It's important, though, you have a background in Math 119 as far as inverses. All right? What's a one-to-one function? How to find an inverse, yada, yada, yada. All the stuff you did in 119. And there's a whole section on it, 119. All right? So I'm going to go to the whiteboard. And give me 1 second to do so. Okay, I'm on the whiteboard. So I want to point out, certainly we are hoping that you're going to read through your notes, and certainly it'd be great if they were printed out, by the way. And what I mean by printed out, maybe you highlight things, say definition. What's the definition of here? F is called one-to-one. You read through it, try to make sense out of it. Maybe go back to what you talked about, Math 100. And I'm going to point out this function over here is not one-to-one. This is not one-to-one. The main reason I'm looking at it, what do I see? I see a horizontal line that hits it 1, 2, 3 times. It's not one-to-one. And certainly in Math 119, where they say, oh, just write down it's not one-to-one because the horizontal line test was used. All right. So go back and review 119 if you have to. Let's go to the next page. What's the problem now? Curves like this, and I really mean that. You're looking at it, you say, gee, I wonder if that's one-to-one. And that might be a lot more difficult to show it's one-to-one, but this is in fact a one-to-one function. Unfortunately, though, if you drew a horizontal line, it looks like it goes through more than once. But I want to emphasize to you here, let me back up over this. If you were to blow this thing up, I mean, really blow it up, what you're going to notice as you move along this path over here, the thing is always increasing. And this can be shown when you take calculus. It's always moving up. In other words, no horizontal line would hit that more than once. All right. Now, granted, we're not at that level of detail yet, but we're hoping you get there. We are. We're hoping you get there at some point. What we want to do is we want to go on to the inverse functions, though. So I kind of maybe just kind of read through. It's important. All right, this is important. I will now be writing x instead of theta. Please bear in mind that x now represents the angle. So if I write this over here, what am I saying? Sine of an angle is equal y. What's y? Y is a ratio. All right. So now x is the angle, y is a ratio. I know this confuses many students, but almost all textbooks do it. It's hard to avoid. The original definitions I gave you back in the beginning have not changed. However, x and y now are representing something. Again, when I write y equals sine of x, what am I saying? Sine of an angle equals a ratio, right? If you've learned the previous material in 119, you'll immediately notice that none of the trigonometric functions are invertible. Let me make sure you understand that. None of the trigonometric functions are invertible. So what we have to do, which we would not do in 119, we need to restrict the domain to make them invertible. And what we'd like to do that, we love to stay close to home. Home in our number system is the origin. So we're going to look at our curves and we're going to determine a region that covers the range of the function but stays close to the origin. The next page. And we're going to deal with one curve at a time. And someone says, what's that curve there? Well, if I look at it, I'm going to claim this to me looks like a rather bizarre looking sine function. Whoops, let me go backwards on that. So I'm going to say this is y equals sine of x. Now, what do you notice over there? What I did was I kind of put a dash line and then a red solid thing to indicate something. And what am I really indicating over here? I'm indicating a portion of the sine function that is invertible that stays very close to home. What do I mean by that? It covers the entire range up to 1, down to -1. It covers the entire range, right? Entire range from -1 to 1 for the sine function, and it stays close to the origin. Now I want to put these points down for you because they're important points. What's this point over here? That would be pi over 2. Yes, you should know from graphing, comma 1. What's this guy over here? It would be minus pi over 2, comma -1. So let me write this over here. We'll get to the question in a second. I'm staying close to the origin and I want to cover the entire range. And I just did that looking at that section. It's the red section. All right. Now, it's really not the sine function. It's the sine function where the angle is being restricted. And the angle is being restricted between pi over 2, minus pi over 2 and pi over 2. All right. We'll go to the questions later. The domain in interval notation is minus pi over 2 to pi over 2. I'm looking at the picture, by the way. Its range in interval notation goes from -1 to 1. All right, let's go to the questions. What does it say? What's the functional notation of the red portion of the graph? Well, we just did that, and it's right over here. That's the functional notation of that red portion of the graph, by the way. It's the functional notation. What am I saying? F of x equals sine x, but we must stick between minus pi over 2. Conclusive. We can touch those points, right? Because we want to make sure it covers the entire range. Okay, what's the domain of that function? Well, we just did that. I'm going to write down the intervals again for you. So minus pi over 2 up to pi over 2. And again, that's the domain. Remember, domain for this problem over here, what's being covered? I'm talking about the red portion. What's the range of it? Well, the range of it, I'm going to go to the next page. We just did it, is going to go from -1 to 1. I'm going to write that down in intervals for you. Okay. Let's go to number 4. Number 4 is something new. What does number 4 say? It says the name of the sine's inverse is arcsine. That's a new word. We haven't seen that before. We also write down inverse sine. We have notation for it. This is the notation for it. Unfortunately, I don't like that notation. I actually prefer this notation. Let me write down, I can put it in black. Arc sine of x. Now someone says, why don't you like that notation? The reason for that, a lot of students misunderstand that notation with the -1. They think it means reciprocal. It's not a reciprocal, it's an inverse function. That is read as y equals the inverse of sine or the arcsine. I actually prefer arcsine. All right. So here's what you need to go back to Math 119. And I'm going to write it down for you. So if this is true, whoops. Give me a second. The domain of this and the range of this should be very easy to deal with. So the domain would be the range of that invertible region of the sine function. So it would be -1 to 1. And the range of this would be the domain of the invertible region of sine function, and that one between -π/2 to π/2. All right. Let me point out where this is in your notes. Arcsine's domain, -1 to 1. Arcsine's range, -π/2 to π/2. Okay. Let's go to question number 5 now. And again, we're hoping you're able to follow what we're doing over here. Label the following graph. It's on the next page. Okay. Okay. I'm going to put my little red thing down. I'll put this over here. By the way, there's a reason we give you graphs. We want you to have good graphs, and a machine did this graph. I'm going to put this in red for you. This curve over here is f of x equals the sine of x, but it's just a partial picture of it, where the domain of this thing over here goes between -π/2 to π/2. That's an invertible region of sine curve. And this guy's range goes from -1 to 1. I'm going to trace the other curve out, and I'm going to do it in blue. Okay, and what's this guy over here? Well, if you remember back to Math 119, what it is, it's a rotation about a line y equals x. When you did 119, they drew a line y equals x in, and they rotated the curve to get its inverse. Well, let's write this down now. What's the inverse going to be called? F inverse. What's the name we have for that? Sine inverse. Remember, I'm not a big fan of that. However, I do use it. I would much prefer to see arcsine. What's its domain? The range of the other guy. So -1 to 1. What's its range? The domain of the other guy. It's a rotation, that's all it is. X becomes y, y becomes x. Range becomes domain, domain becomes range. All right, I'll put some points down here for you. I wonder what that point is over there. Well, it's got to be -1. It has to be. What's this point over here? It has to be 1. All right, let's put this point over here. It might be easy for me, but in red for you. I know sine really well, don't I? So it's going to be pi over 2, comma 1. So this will be pi over 2. What are we doing? We're rotating that point about the line y equals x. All right, let's keep going. What's this point over here? The red point, right? That's going to be minus pi over 2, comma minus 1. Well, let's put this blue point down. It's rotation of a point. X becomes y, y becomes x. Again, the blue version is the arcsine function. The red version is the sine function. Once you master this, and you do want to master it, you don't want to memorize it. You want to master what we just did over here. Once you can master one, the other should fall into place. All right, look at the next picture. And someone says, I wonder what this is a picture of. Well, I'm looking at it, and I'm going to say this is clear as day to me. This is definitely the cosine function. So I'm going to point out why they draw this region. They stayed close to the origin, and they try to cover its entire range. And what's the range going to be? It goes up to 1 and down to minus 1. They stayed close to the origin and want to maintain its entire range. I did a pretty good job of that, right? This is definitely a 1-to-1 region of the cosine function. Let's put the points down now. All right, one point at a time. What's this point over here? 0, comma 1. What's this point over here? Pi over 2, comma 0. What's this point over here? Pi, comma minus 1. So I'm going to claim over here, this red curve over here, it's really not the cosine function, it's part of it. With the understanding domain of this guy over here goes from 0 to pi, and the range of this guy over here goes from minus 1 to 1. All right, let's go to the next page. One question at a time, right? Now let's take a look at it. And we just did it, right? I mean, we just looked at the red portion. And what was the domain? Well, if you can't remember, flip back in your notes. 0 to pi. What was the range of that function? Oh, I'm sorry. This is the notation. I'm sorry. What's the domain of that function? 0 to pi. I didn't read the question. I'm sorry about that. What's the range of it? Minus 1 to 1. That just comes from me remembering the graph I just did. All right. Here comes the part where some people say, oh, what am I going to do now? Well, I guess what I'm going to do is read it to you, right? So it says the name of the cosine's inverse is arc cosine. Some people also write down inverse cosine. Let me put this over here. I got to be honest with you. I don't like that. I don't like the minus 1 over there. So I prefer to write down something different. So y, let me go back to black. Y equals, and again, you could say inverse cosine. That's inverse, not reciprocal. It's really descending as arc cosine of x. I know that's difficult. All right, let's go back over this. Domain and range. Okay, here comes the problem. The domain of this thing would be the range of the invertible region of the cosine. And what's that going to be? Minus 1 to 1. The range of this thing is going to be the domain of the cosine. And what was that going to be? 0 to pi. Let me just point out where that is over here. Let's go to the next page. I got a picture. I'm going to blow it up. I'm going to label it. Before I do anything, I want to put the line in y equals x. All right, I'm going to do the red curve first. Put this over here. Put some points down for you as well. I think we've done these points before many times, right? Let's see if we can do that. So let's see, we have 0, comma 1. This point over here is going to be pi over 2, comma 0. And this point over here is pi, comma minus 1. This is the function f of x equals the cosine of x, where the domain of it goes from 0 to pi. It's an invertible region. And the range of it goes from minus 1 to 1. All right, let's put the other curve down, and I'm looking at it. And certainly, when I look at things, and you certainly may look at something and say it's different when you look at it, but I'm seeing something. I'm going to put this over here. Okay, I'm going to start talking points here. And as I do that, I want to mention what it's doing. It's a point rotated. What's this point? I'll write it down for you. It will be 1, comma 0. What's this point? I want to point out what it is. It's a rotation of that point about this line. So that should be easy. What's that going to be? 0, pi over 2. All right. What's this point? I want to point out it's a rotation of this point about this line. So what's it going to be? Well, I'll write it down for you. It's going to be minus 1, comma pi. So I can write down what this is now. If it's a rotation about the line y equals x, it's the inverse function. So what is it going to be? F inverse. Well, what's the inverse of the cosine called? Oh, inverse cosine. It could be also written as arc cosine. What's its domain? Well, the domain of this is the range of the other guy, so minus 1 to 1. And you could look at the picture for that too. What's the range of this? The domain of the other guy, 0 to pi. All right, that's done. Let's go to the next one. Well, I got to get to the picture first. Let's take a look at that. Blow it up. And what did they do? They gave me an invertible region of the tangent function that is close to the origin, but covers everything. All right, goes on forever. So let's write this down. So f of x is equal to the tangent of x. It has a domain, at least the red portion does. What's the domain going to be? Minus pi over 2. No, it doesn't touch that. That's asymptotic. Up to pi over 2. What's the range of it? All real numbers. All right. Let's go back. And let's talk about the functional notation we just did. We just discussed about it right over here. The only difference is I wrote the x down as an interval between minus pi over 2 and pi over 2. That's the only difference. The next one, question, right? The domain of it. Well, we just did that. I wrote an interval notation, minus, whoops, sorry about that. Made a mistake. Can't touch minus pi over 2. It's asymptotic. What's the range of it? All real numbers. And again, we're talking about the red portion of the curve. All right, let's keep reading. Let's take a look. Take a look. The name of the tangent's inverse is arctangent. We also write down inverse tangent, and that's written over here. Now, of course, I'm going to write down, y. Whoops, I did it again. Equals inverse tangent. Again, that minus 1 has nothing to do with reciprocal. It's read as inverse tangent, and it's also read as arctangent. Okay. All right, so what are we going to do? I think I could figure this thing out just by this is my third time. So I'm going to write down domain, and I'm going to write down range for this. Well, what's the domain going to be? It's going to be the range of the tangent's invertible region, which is minus infinity to infinity. What's the range of it going to be? The domain of the invertible region of tangent function, which is minus pi over 2 to pi over 2. Again, these things are written down over here. That's minus infinity to infinity. To the next page. And I want to point out this thing is written in inequality notation. I'm going to write in interval notation. And let me just blow this up. I did make a mistake by putting a square bracket there. I'm going to erase it now. Let's write this down. Okay, that's done. They want me to label this thing. And it looks pretty busy to me. So I'm going to do one thing at a time. I'm hoping you can follow that. I'm going to go for the familiar. It's here. And again, the curve's really busy. That is f of x equals tangent of x. However, it's not the complete tangent curve, just part of it. And I'm going to put domain down for this. And the domain for this thing is minus pi over 2 to pi over 2. And the range of this is going to be all real numbers. I'm also going to label these asymptotes. This asymptote here is x equals minus pi over 2. And this asymptote over here is x equals pi over 2. And what did they do? They rotated that curve. Not easy, is it, to rotate through that line over there? That's the line y equals x. And what would they get? They get a curve that looks like this over here if they rotate. And what do we know that thing to be? An inverse function. I'm going to write this down now for you. So if it's the inverse function, we write down f inverse. That's arctangent or inverse tangent. I think I can write down domain and range now, right? What's domain? Well, it's the other guy's range. Exactly what you did in math 100. 119, I'm sorry. And the range well, I think I can finish this guy off now, right? What's this asymptote over here? Y equals minus pi over 2. And this line up there is y equals pi over 2. All right. That's about it. We got everything covered. Thank you.